Ruofan Liu from the National University of Singapore. Today, I'm pleased to share our research on less defined knowledge and more true alarms, reference-based phishing detection without a predefined reference list. This work is a joint work developed by Shanghai Jiao Tong University and the National University of Singapore. There has been a significant rise from 26K victims in 2018 to an alarming 300K victims in 2023. This underscores the growing threat of phishing attacks and the urgent need for effective detection solution. The state-of-the-art phishing detection relies on a reference list of known brands and their representations. This method works by comparing the target website's domain and content against this predefined list. For example, if the phishing site abc.com attempts to impersonate adobe.com, the mismatch between the domain and the brand can trigger a phishing alert. While effective, traditional reference-based detection still suffer from two major limitations. Firstly, they are heavily reliant on maintaining and updating an extensive reference list, which is not only resource-intensive, but also limited in handling new and emerging phishing sites that are targeting a brand outside the reference list. Second, they primarily focus on the visual semantics of the web page, such as logos and layouts, which may overlook other critical elements, such as textual content. We introduced PhishLM, a novel phishing detection system that operates without a predefined reference list. Instead, PhishLM uses advanced language models to look and read the content of a web page, analyzing logos and the textual semantics to identify potential phishing threats. Our rationales are: LLM is a comprehensive knowledge base. It may include far more extensive brand knowledge than any predefined reference list. In addition, LLM is naturally good at reasoning and understanding the textual semantics, which is crucial for tasks such as understanding the credential-taking intention of a phishing web page. PhishLM functions by first recognizing brand logos and extracts its description. The description will be fed into LLM to infer its target brand. To prevent potential misinformation produced by LLM, we validate the target brand by comparing the web page logo with all alternative logos on the web. Then we check for brand domain inconsistency. To understand the credential-taking intention of the web page, PhishLM then executes the credential-taking prediction module and CRP transition module. The web page description will be fed into the LLM to determine its credential-taking status. If the web page is not credential-taking, it will try to predict the UI that most likely transit to a credential-taking one and auto-click this UI. On an updated screenshot, the CRP prediction will be repeated again. With both the brand domain inconsistency and the credential-taking intention, we raise the phishing alert. PhishLM demonstrated significant improvement in recall rates on a DynaPD phishing keys dataset. Meanwhile, the runtime is reduced by 2.6 seconds compared to DynaPhish, which does online expansion of brand reference lists. In an open-world environment, PhishLM can discover 2 times number of phishing. With a higher number of distinct target brands covered, majority of which are not included in the static reference list. To see PhishLM in action, you can visit our demo site at the URL provided. The left panel provides options to adjust the default hyperparameters. Users can input the URL to scan. The screenshot will then be captured. It will first perform several pre-processing steps to generate the logo description and the web page description. Then LLM will infer the target brand. Here it has successfully returned the target brand as OneDrive. Next, LLM will predict the credential-taking status. In this example, the answer is A. This is already a credential-taking page. Lastly, the final decision is reached. Phishing can be deployed in various scenarios. Scenario 1 is as an URL consumption service. Phishing can be integrated at the email server side or as a browser plugin to scan a stream of URLs. Scenario 2 is as a threat intelligence feed. Phishing can actively scan the emerging websites and report zero-day phishing alerts. Scenario 3 is to collaborate with the web hosting providers. Web hosting providers can use our tool to monitor the potential phishing sites that are exploiting their hosting services and effectively take them down. In conclusion, empowered by LLM, phishing LLM improves the brand knowledge coverage without the need of expanding the reference list. Meanwhile, phishing LLM improves the explainability by looking at the enriched semantics of the web page. For more information, please check our code and our website. Thank you for your attention.